Content you're going to cover here is the SDLC, the waterfall model, object-oriented analysis and design, rapid application development, joint application development, agile methodologies, Scrum, extreme programming, and prototype. System development is basically the standard process followed to conduct all the necessary steps to analyze, design, implement, and maintain information systems. The system development lifecycle is thus the traditional methodology that is used to develop, maintain, and replace information system, which is usually a circular process with the end of the project's useful life cycle leading to the start of system development life cycle. Therefore includes planning, analysis, design, implementation, and maintenance. Start off with planning. As we all know, when you start planning something, so this is where you first identify the need for a new or an enhanced system. Why do you need to develop a new system? You identify the objectives, you analyze, prioritize, and arrange the objectives. At this stage, the scope of the proposed system is determined. The baseline project plan is also developed. After planning, the next phase is analysis, where a careful study of the current system, which could be manual or computerized, that might be replaced or be enhanced, is done. Here, the system requirements are studied and structured, and the output of this process is the description of the solution recommended by the analysis team. The next stage, we call it design, and here is after the analysis stage, the requirements are converted into alternate solution into logical and physical specification, where the logical design or the logical specification is part of the independent of any specific hardware or software platform. So that means there is a design of the system that maps how the requirements will be made by doing a formal design, but that is not as per the hardware or the software that system that will use. While physical design is the logical specification of the system from the logical designs, which are transformed into technology-specific details from which all system construction can be accomplished. In this case, it means you have the hardware and software consideration. Implementation is where the information system is coded, tested, installed, and supported in the organization. The new systems become part of the daily activities of the organization, and therefore this is where the programmer's work is done, where it means coding, writing the software, requirements, designs, writing the designs and converting them into codes using the right programming language, testing to locate and remove errors. The system, after has been developed, is installed in the organization and supported in terms of training and any other activity that needs to be done. And therefore, the system becomes part of the daily organization of the activities. Maintenance starts from the time the starts to be used, the system starts to be used. So the phase in which an information system is methodically repaired and improved. The organization needs may change over time, requiring changes to the system. So that means any change that needs to be done for the purpose of correcting errors, preventing errors, updating the system, or adapting the system to the environment. And that now continues until the system becomes obsolete, which now we start developing a new system, or the organization start developing a new system, and that is why it makes the system to be a cycle, because we go back to plan. Advantages of SDLC is one, project management is easy to manage projects because The activities are broken down into phases, and therefore it will be easy to plan, evaluate. Documentation, SDLC calls or gives ways of how to document and capture everything that is being done. And then SDLC is a tried and tested techniques. So it means whatever is usually used in terms of, for example, the data flow diagrams, the entity relationship diagram, the tools used are tools that have been used for a long time. Therefore, they have been tested in many cases. Disadvantages of SDLC: one is inflexibility, and that means when you go through the phases, when you start from one phase going to the next, it becomes a bit hard to change things because it has been arranged as per phases. Narrow focus, it tends to be used to develop low-level operational system where things are structured, they have to be done in a specific way, and therefore it may not be used for wider focus kind of system. Then old-fashioned techniques that may be found inappropriate to be used in the current modern technology web-based solutions. And then time and cost overrun. It may take a lot of time when you're developing the system and incur a traditional waterfall model, also referred to as the linear sequential life cycle model. Each phase must be completed before the next phase can begin, and there is no overlapping in the phases. The model is the earliest of the SDLC approach that was used for the software development. So it means it is an approach to system development, SDLC. So it's one of the SDLC. And the stages, as you can see in this diagram, we start from planning, then we go to analysis. So it means when you're at analysis stage, you cannot go back to planning. That is why it's called a waterfall. Next, you have logical design. When you're at logical design, you cannot go to analysis. You can only go to physical design, then implementation, and lastly, waterfall model application. It is applied or appropriate where requirements are very well documented, clear, and fixed. Product description is stable. It does not mean keep on changing. So it means the requirements or what is required of that product will not change. Technology is understood and is not dynamic. There are no ambiguous requirements. Sufficient resources with required expertise are available to support the product, and the project is short. Waterfall model advantage. The first is that it's simple and easy to understand and use. Works well for smaller projects where requirements are very well understood, easy to arrange tasks, easy to manage due to the rigidity of the model, clearly defined stages, process and results are well documented, phases are processed and completed one at a time, and well understood milestones. Disadvantage: no working software is produced until late during the life cycle. High amount of risk and uncertainty. Not a good model for complex and object-oriented projects. Poor model for long and ongoing projects. Not suitable for the projects where requirements are at a moderate to high risk of changing and cannot accommodate changing requirements. Object-oriented analysis and design is based on objects rather than data or process. The model combines data and process into a single entity called objects. So an object is where we consider real-world things, or in other words, in object-oriented analysis and design is what we call an object-oriented approach, where real-world things are considered as objects. So as an object is a structure that encapsulates attributes and methods that operate on those attributes. So an object is defined by attributes and it has methods. Inheritance is about hierarchical arrangement of classes, enabling subclasses to inherit properties of a superclass. Object class is a logical grouping of objects that have the same attributes and behaviors, what we usually call as object template. Application development is a method of developing information system which uses prototyping to achieve user involvement and faster development, focuses on quickly building a working model of the software, getting feedback from users, and then using it to update the working model. And a final version is developed and implemented after several iterations of development. The RAD phases are requirements planning, user design, construction, and cutover. These phases relate to the system development methodology cycles, where system requirements planning relates to the planning stage, user design relates to the design stage, construction relates to the implementation stage, and cutover relates to the still implementation and maintenance. Application development is the other approach to system development, and this means structured process in which users, managers, and analysts work together for several days in a series of intensive meetings to specify or review system requirements. The primary purpose is to collect system requirements simultaneously from key people involved with the system. It enables conflict resolution. Participants include JAD session leader, who organizes and runs the session, manager of the work groups, system analysts, who are members of the system analysis team, scribe, who records notes from sessions, information system staff composed of programmers, database analysts, information system planners, and data center personnel, users of the system, and nursery sponsor executive company, or in other words, the sponsors were part of the executive in the company. Methodologies are approaches that promote a self-adaptive software development process, and they focus more on individual. As software is developed, the process used to develop it is refined and improved through a review process done by the development team. There is less focus on process and more focus on people involved in the project. So this approach is used for mostly modern system development that you have today, and you find that there are current systems that need to be developed, but the traditional methodologies that have been there are insufficient to support them. So we have better ways of developing system whereby the people who are being involved, the expertise, will have an input, and therefore the developers will develop the system and use or mix different ways of coming up with the system. So agile methodologies share three key principles: a focus on adaptive rather than predictive methodologies. So the developer uses adaptive approaches based on what they want to do and what they are developing. Focus on people rather than the roles. They focus on the people that are developing on that system or that information system and what they can do and their capability, and then focus on a self-adaptive process. So software development methodologies are adapted from engineering generally do not fit the real-world software development. So therefore, every project needs to be handled differently, and the existing methods need to be tailored to best suit the project requirements. So Agile takes care of that. Agile process is recommended if the project you are tackling involves unpredictable or dynamic requirements, responsible and motivated developers, customers who understand the process and will get involved. Scrum is another popular methodology that is used for Agile. Scrum teams with associated roles, events, artifacts, and rules. Each team consists of 3 roles: the product owner, the development team, and the Scrum. So that means these people work together to achieve the best outcome of the system development. Scrum is designed for speed and multifunctional process product release, and it starts with planning meeting by looking at what needs to be delivered, how will the team accomplish that work, and then daily startup meeting helps to evaluate progress that have been made within the past day and what needs to be. Extreme programming involves short incremental development cycles focused on automated tests written by programmers. Customers monitor the development process. Coding and tested are related parts of the same process. The advantages of extreme programming is that one, there is increased communication among developers, higher levels of productivity, and higher quality code. Is the other approach to system development. It involves creating a prototype, which is a preliminary version of part of a framework of an information system, what we usually call a working prototype, and it is a model that represents the whole system, which can be reviewed by users. And this is where a prototype is created using few requirements, and then the developers develop a prototype, and the prototype is given by users to review it. It's an iterative process where users suggest modifications before further prototypes, and the final information systems are built. So the prototypes are modified every time the developer gets suggestions from users, and that happens iteratively. Characteristics is one, it's rapid, involves small teams, there is a lot of user involvement, and frequent review and testing. So prototyping, evolutionary prototyping begins by modeling part of the proposed system. If successful, those parts evolve or they become part of the system, and prototypes becomes the actual production system. Throwaway prototyping, the prototype is not preserved once the system is built. Quickly developed as a model, the requirements gathered from the prototypes are used to create a new system, and the prototypes used are thrown away. Prototyping application is mostly used where user requirements are not clear, and therefore you need to get more information from users. Few users are involved in the system, and therefore it will be easy to coordinate. Designs are complex and require concrete form to evaluate. All want specific system requirements as communication problems have existed in the past. And then tools and data are readily available to rapidly build prototype. Drawbacks of prototyping. They tend to avoid creating formal documentation because of the iterative process. Challenging to adapt to other potential users. And then SDLC checks are often bypassed.